Hello grade 7 learners, welcome to another exciting math lesson. We are now on quarter 4, week 4 of our mathematics lesson. And today, we are going to talk about graphs. Do you know what a graph is? Very good. Let's now define graph. A graph is a visual representation of a set of values in relation to another set. It is used to present data being presented in tabular form. In some references, it is defined as a diagram that represents the variation of a variable in comparison with that of one or more other variables. The graph also has important features. We have the title of the graph and the two elements or variables that are being analyzed. There are different kinds of graphs, and that is what are we going to talk about in this lesson. So we have pie chart, bar graph, line graph, histogram, and ogive. First is the pie chart. It is also called a circle graph or a pie graph. It is represented by a circle divided into parts. It shows the relationship among parts as well as the relationship of a part to the whole. The data are presented in percentage form and represented in the circle graph by an equivalent fractional part of a whole. So, let's have an example. This is a circle graph of the choices of ice cream flavor of 60 students. So we have 6%, which is tinapa, 20% for mango, 40% for Rocky Road, 24% for ube, and 10% for mocha. So, how are you going to construct a pie chart or pie graph? Here are the steps. To construct a pie chart, recall the lesson on measures of central angles. In above example, the percent rate for each chosen ice cream flavor is given. The rate is multiplied by 360 degrees, which is the measure of one full circle. So for flavors, we have here the flavors mango, Rocky Road, ube, mocha, and tinapa. So first, mango. 20% of the student chose mango as a flavor. So all we have to do is to multiply it by 360, and that is equal to 72. Same with number 2, Rocky Road, 40% of 360. So, all we have to do is to get the 40% of 360, and that is equal to 144. Next, we have ube. 25% of the student chose ube. So, we are going to get the 25% of 360 degrees, and that is 90 degrees. For mocha, 10%. So 10%, we are going to get the 10% of 360, and that is 36 degrees. And last is tinapa, which is 5%, and that is equal to 18 degrees. Now, using a protractor, you are ready to determine the measures of each sector of the circle representing each item in terms of degree. Since we already have the sector divided in terms of degrees, now we are going to determine the number of students who chose a particular flavor of ice cream. So all we have to do is to multiply the corresponding percent for each ice cream flavor by the total number of the students. So for number 1, 20% of the student chose mango. So we are going to multiply we are going to get the 20% of 60, which is the total number of the student, and that is equal to 12. So 12 students chose mango flavor. Same with Rocky Road, we are going to get the 40% of the 60 students, and that is equal to 24. For number 3, we are going to get the 25% of the 60 students, and that is equal to 15. For Mocha, 10% of the total number of the student, which is 60, and that is equal to 6. And for Tinapa, we have 5%, and that is equal to 3. And that's it. You can now draw a pie chart. You have the sector of the circle representing each item in terms of degrees, and you already determined the number of students who chose a particular flavor of ice cream. The second type of graph is bar graph. Bar graph is used for making direct visual comparison of data. The bars in the graph may be drawn horizontally or vertically to represent the information. So let's have an example. This is the charity donation of each grade level in high school. So, written vertically, we have the grade level, which is grade 7, grade 8, grade 9, grade 10, grade 11, and grade 12. And written horizontally, we have 0 to 45,000, which is the donations. So this is an example of horizontal bar graph. While for vertical bar graph, we have here the SIM card used by students per grade level. So on the left side, we have 0, 5, 10, 15, 20, 25, and 30. And written horizontally, we have the grade level, which is grade 7 to grade 12. So it has legend, which is if the student is using Globe as a SIM card, we have green. If it is using Smart, we have gradient brown. For Talk and Text, we have brown with lines, and for Sun, we have for Sun subscriber, we have gray, and for non-subscriber, we have white. So again, for bar graph, we have two types. We have the vertical and the horizontal graph. Next, we have the line graph. A line graph is used to show changes between two quantitative data. Usually, one of the quantities under consideration is time. The relation between this data is graphed on a rectangular coordinate plane. The quantity time is usually plotted along the vertical axis, and points are plotted based on the relationship of quantities, and those points reconnected by a line. That's why it is called line graph. So here's an example of line graph. We have the monthly electric consumption of a local resident for 12 months period. So it states earlier that time is important in line graph. So the time here is a 12 month, which is January to December, which is written on the horizontal axis of the line graph, while written in the vertical axis is the electric consumption. So the graph above indicates the trend of electric consumption over a period of 12 months from January to December. Using a line graph, you can now identify which month has the lowest consumption and which month has the highest consumption, and was it increased as the months passed by or decrease. The next type of graph is histogram. A histogram is a graphical display of data using bars of different heights. It is similar to a bar chart, but a histogram groups numbers into ranges and shows no gaps between the bars. The height of each bar shows how many fall into each range. The histogram is constructed as a sequence of vertical rectangles. Unlike in bar graph, we have vertical and horizontal. But here, in histogram, we only have vertical rectangles. Each rectangle is drawn with the base equal to the class interval and a height corresponding to the class frequency. Here is an example of histogram. We have parts of histogram, which are the title, x-axis, y-axis, and the bars. So the title describes the information included in the histogram, while the x-axis are intervals that show the scale of values which the measurements fall under. Y-axis shows the number of times that the values occurred within the interval set by the x-axis. And the bars, it is the height of the bar shows the number of times that the values occurred within the interval, while the width of the bar shows the interval that is covered. Creating a histogram provides a visual representation of data distribution. It is used to summarize discrete or continuous data. Histograms are display of large amount of data and the frequency of the data values. It provides a visual interpretation of numerical data by showing the number of data points that fall within a specific range of values called bit. Let's now proceed to the distributions of histogram. First, we have the normal distribution histogram. A normal distribution looks like this, where points on one side of the average are as likely to occur as on the other side of the average. So again, this is a normal distribution. We also have bimodal distribution histogram, where there are two peaks. That is why it is called bimodal. In a bimodal distribution, the data should be separated and analyzed as separate normal distribution. We also have a right-skewed distribution histogram. It is called a positively skewed distribution. In a right-skewed distribution, a large number of data values occur on the left side with a fewer numbers of data values on the right side. A right-skewed distribution usually occurs when the data has a range boundary on the left-hand side of histogram. Like for example, a boundary of 0. Next is a left-skewed distribution. It is also called negatively skewed distribution. In a left-skewed distribution, a larger number of data values occur on the right side with a fewer number of data values on the left side. A left-skewed distribution usually occurs when the data has a range boundary on the right-hand side of the histogram. For example, a boundary such as 100. And last, we have a random distribution histogram. Though a random distribution histogram lacks an apparent pattern that has several peaks. In a random distribution histogram, it can be the case that different data properties were combined. Therefore, the data should be separated and analyzed separately. So in distribution of a histogram, we have normal distribution, bimodal distribution, right-skewed distribution, left-skewed distribution, and random distribution. And the last type of graph is the ogive. So an ogive is sometimes called a cumulative frequency polygon. It is a type of frequency that shows cumulative frequencies. In other words, the cumulative percent are added on the graph from left to right. An ogive graph plots cumulative frequency on the y-axis and class boundaries along the x-axis. It's very similar to a histogram, only instead of rectangles, an ogive has a single point markings where the top right of the rectangle would be. So we have 5 types of graphs. We have pie chart, bar graph, line graph, histogram, and ogive. And that's it for now. Till next time, keep safe and God bless.